Hey everybody, it's Mr. Campbell here with Mathematical Anarchy, and today we're talking about average rate of change. To start off, what can we say about a 120-mile trip that takes place over a 2-hour time period? Just thinking about this idea of 120 miles over 2 hours, it sounds like a fraction. 120 miles over 2 hours. So if we go that route and we simplify what we have here, 120 divided by 2 gives us 60, and our units end up being miles per hour. So what we can say is that the average speed on our trip was 60 miles an hour. We could have been going faster or slower, but all we know is that we have 120 miles, we have some sort of change in distance, we have 2 hours, right? We started, we finished, we have some sort of change in time. And that's what we're dealing with, a change in distance over change in time, and we know in this instance it gives us our speed, and our units are going to be in miles per hour. Now, what if the trip only took 90 minutes? Okay, if we set up another ratio, 120 miles over 90 minutes, we can reduce this to 4/3 of a mile per minute. Now, it doesn't tell us a lot if we're driving a car. That's not the type of units that we generally use. It's a correct calculation, and it's equivalent, but it would have been more helpful if our answer was in miles per hour. So instead of using minutes, let's go ahead and substitute for hours. So 90 minutes is an hour and a half, or 1.5 hours. So if we go ahead and use 1.5 hours and do the division, 120 divided by 1.5 gives us 80. So that's miles per hour. Well, unfortunately, in Arizona, the maximum speed limit is 75, so this would be speeding. So for instance, it's not possible to go 120 miles, like from Tucson to Phoenix, in 90 minutes without breaking the law. So what we're talking about in this example is called average rate of change. We have a ratio comparing how two quantities change in relation to each other. A ratio is a fraction. And for change, we're going to use the Greek letter delta to help communicate this idea of change in, okay, using symbols and not having to write it out. So ratio is connected with the word rate, and for change, we're going to think about the Greek letter delta. So ultimately, we're looking at the change in one thing over the change in another thing. For our next example, what can we learn about the temperature in Tucson by exploring the average rate of change? First thing is we think about the change in the temperature over a change in time. For units, we're going to have degrees Fahrenheit per day. So this is going to tell us, on average, how much the temperature changes over a time period. So let's say we're talking about September 5th to September 10th. We need to figure out our change in temp and our change in time. So we can set up a ratio. To find our change in temperature, we need to find the difference, okay? If it's at 105 now and it is 93 after, it's gone down 12 degrees. To find that, we have 39 minus 105, what it is on the 10th minus what it is on the 5th. And that's all divided by 10 minus 5. So that's going to give us negative 12 degrees Fahrenheit over a 5-day time period. So that's negative 2.4 degrees Fahrenheit per day. So it tells us that the high temperature dropped an average of 2.4 degrees per day during that 5-day time period. We could see from the table it didn't drop exactly 2.4 degrees per day, but on average, that's how much it went down. What about between September 8th and September 12th? Again, we have a change in time. We have a change in temperature. We can start with our ratio. We need to find the change in temperature. Well, 98 degrees minus 98 degrees, we can see the change in temperature is 0. Okay, 12 minus 8, that's a 4-day time period, so we have a 0-degree change over a 4-day time period. So the average change was 0 degrees Fahrenheit per day. Does that mean that the temperature didn't change? No, we can see by the table it did. It went down and then it came back up. So the average change in temperature was 0 over those 4 days. For our last example, we'll take a look at the number of monthly deaths in Arizona between the year 2020, represented in red, and the average of the 5 years prior to that, represented in blue. We're going to compare the change in deaths over the change in time, and that's going to be measured in people per month. So let's say we wanted to investigate this increase in deaths that's occurring from May to July, right? Our change in time, call it delta T, is equal to 2 months. For the average, our change in deaths, delta D, we have 4,881 minus 5,009, which is equal to negative 128. So we have a ratio delta D over delta T of negative 128 people over 2 months. So that gives us an average decrease in deaths of 64 people per month. It's negative, so it's decreasing. And we can see that in the graph. The number of deaths on average was decreasing. Now we can compare that to this year. In which case we have 7,903 minus 5,800, and that's equal to 2,103. So forming our ratio, change in deaths over change in time, delta D over delta T, we have 2,103 people over 2 months, and that's equal to 1,051.5 people per month. So we can compare those two and see that definitely in a time when normally we'd be seeing a decrease in the number of deaths per month, we have a drastic increase in deaths. Now comparing to a different time frame, a different 2-month time frame, from August to October, again, we have 2 months. The change in deaths is actually 0. And so in this case, 0 over 2 gives us 0 people per month. Okay, it doesn't mean that the number of deaths didn't change. It did in between. Okay, it didn't remain the same, but on average, there was no difference. So with average rate of change, we've been talking about making a ratio, comparing how one thing changes to how another thing changes. We've seen several results. Whenever our average rate of change is negative, we can see that corresponds with our values decreasing. Whenever we see the average rate of change being positive, we can see that's associated with our data increasing. And when our average rate of change is 0, it could be an indicator that something is remaining constant, but that's not always guaranteed, as we've seen in the examples here. So now that you've had a chance to explore average rate of change, try the practice, come up with any questions, and be ready to ask next class. Good luck.